Good morning, students. Actually, in this class, I am going to teach you some of the example problems to find the function is analytic or not using CRE equations. In last video lecture, I taught you about what is analytic function and how the given function is said to be analytic. For that, we determined Cauchy-Riemann equations, whether the given function satisfies the Cauchy-Riemann equations, then that function is said to be analytic. Similarly, we saw about the sufficient condition for the given function f of z to be analytic. What it states, the sufficient condition for a function f of z that is equal to u plus iv is to be analytic at all the points in a region capital R or a domain D. Then Cauchy-Riemann equation is dou u by dou x that is equal to dou v by dou y, dou u by dou y that is equal to minus dou v by dou x. If the given function satisfies these derivables, then it will be a analytic function. And also we should verify whether this dou u by dou x, dou u by dou y, dou v by dou y and dou v by dou x are continuous functions of x and y in the region R. So when these two conditions will satisfy, then the given function is said to be analytic. So again I will tell you, and also I will give you CR equations in polar form also. Dou u by dou theta that is equal to minus r dou v by dou r, dou u by dou r that is equal to 1 by r dou v by dou theta. This is a extra equation I am telling you, CR equation in polar form. Okay, so now we will see some of the example problems to find the function is analytic or not using CR equations. Okay. Now we will see first problem. Determine whether a function f of z or z is equal to x plus iy is analytic or not. Okay. For that, for every problem to solve whether the function is analytic or not, first you should find out u and v from the given function. Okay, first you should find out u and v for the given function. That is, you should separate real and imaginary part first. After that, you should find out dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Whether it satisfies these equations, CR equations, then it is analytic, and also if it is continuous also in that region. Okay, now I will see. So f of z is equal to u plus iv. Okay, u plus iv. But we know z is nothing but a complex x plus iy, combination of complex variable x plus iy. Now you separate and compare real and imaginary parts. What will be here the real part? You should compare this u, x and v this. Therefore, u is equal to x, but v is equal to y. Okay, u is equal to x and v is equal to y. So now we calculated u and v. Now then you calculate dou u by dou x that is equal to, when differentiate this equation it will given 1. Then dou u by dou y that is equal to 0. Then dou v by dou y, when you are differentiating, then you will get 1. Then dou v by dou x that is equal to 0. So according to CR equations, we know dou u by dou x is equal to dou v by dou y, and dou u by dou y that is equal to minus dou v by dou x. You see, dou u by dou x that is equal to dou v by dou y, which is nothing but 1 is equal to 1. Okay. Then dou u by dou y is 0. Similarly, dou v by dou x is equal to 0. So the above equation satisfies CR equations. Okay, the above function, the given function satisfies the CR equations, and also this partial derivative of dou u by dou x, dou v by dou y, dou u by dou y, dou v by dou x are continuous. Therefore, this function is a analytic function. Okay. Now we will see another example. Determine whether function 1 by z is analytic or not. Okay, so we know z is equal to x plus iy. The f of z is equal to u plus iv. So f of z, that is equal to u plus iv, that is equal to 1 by z, or f of z, that is equal to 1 by x plus iy. Okay, z value you substitute here, then u plus iv is equal to 1 by x plus iy. Now we want to find out the value of u and v. So here there is no proper way. So in order to find out this value, you see here I will write this 1 by x plus iy, that is equal to 1 by x plus iy. You multiply both multiply and divide by x minus iy on both sides. So both numerator and denominator. Therefore x minus iy divided by x minus iy. So we are multiplying and dividing. So what it will come? X minus iy. When you are multiplying this, then x square, then minus of y square, that is minus I square y square. So minus I square is nothing but minus 1. Therefore that value becomes x square plus y square. So instead of 1 by x plus iy, I will substitute this value here. Okay, now you easily separate. This is u represent x divided by x square plus y square, then v is equal to minus y divided by x square plus y square. So now we separated real and imaginary part. Now what we want? We want the derivatives. You see, dou u by dou x, partial derivative with respect to x. So dou u by dou x. This is, you remember this formula. We know d by dx of u by v. In this method, if it comes, then formula is v into d by dx of u minus u into d by dx of v divided by v square. So this is the formula we know already, that is d by dx u by v format. Then the value should be v into d by dx of u minus u into d by dx of v divided by v square. Now apply this formula here. So here v is nothing but x square plus y square. So this is v here. This is u by v formula. Okay. Now x square plus y square divided by x square plus y square the whole square. It should be v square here. V square na? This v square comes here. Then what will be the value? V x square plus y square into dou by dou x of u. X is differentiated, then it will become 1 minus x into 2x, because x square y square, that is x into d by dx of v. V is nothing but what? Here x square plus y square. So when you are differentiating this, then this becomes 2x. Therefore x into 2x divided by. Actually here we are taking u and v. Don't confuse this and this. Okay, this is separate differentiation formula. Okay, right. So when you are solve this, x square plus y square minus 2x square divided by x square plus y square the whole square. So from this you will find out dou u by dou x, that is equal to y square minus x square divided by x square plus y square the whole square. So we found first dou u by dou x. Then we should calculate v now. V is equal to, we know, minus y by x square by y square. We should apply the same formula. Then dou v by dou y, that is equal to x square plus y square into minus 1 minus of minus y 2y divided by x square plus y square the whole square. When you solve that, you will get dou v by dou y, that is equal to y square minus x square divided by x square plus y square the whole square. So now you found dou v by dou y. Then you should find out dou v by dou x. Dou v by dou x is the same formula, that is the d by dx of u by v formula. So you will get x square plus y square. Here y term is 0, so y becomes 0, minus here y term is there. Then when you are minus y into when you are x square plus y square was differentiated, then x square, so it becomes 2x. Therefore 2x divided by x square plus y square the whole square. Therefore, dou v by dou x is equal to this value. Then similarly, dou u by dou y you calculate, and we will get dou u by dou y equal to minus 2xy divided by x square plus y square the whole square. Now, hence according to, so we calculated all the derivatives with respect to x and y. Now, according to CR equations, dou u by dou x that is equal to dou v by dou y, and dou u by dou y that is equal to minus dou v by dou x. Compare all the values of 1, 2, 3, 4. We will get y square minus x square equal to x square plus y square the whole square, that is equal to y square minus x square divided by x square plus y square the whole square. So it is satisfied. Then the second equation also satisfied, that is dou u by dou y that is equal to minus of dou v by dou x. This is also satisfied. Hence CR equation is satisfied and proved. The given function 1 by z is analytic. This is also continuous. This is also when these derivatives are also continuous. So it satisfies both the conditions. Hence the given equation 1 by z is analytic. Okay. Now we will see another equation. Another example. Show that the function f of z that is equal to e power z satisfies the CR equation or not. Okay. Now for that is f of z equal to e power z, but we know z is equal to x plus iy. Therefore, f of z is equal to e power x plus iy. So you see this term, that is e power a plus b, that it will be separated as e power a and e power b. Similarly, so f of z is equal to e power x into e power iy. So we separated. But for this e power iy, we know e power I theta that is equal to cos theta plus I sin theta. We know this. Therefore, e power iy is nothing but cos y plus I sin y. Okay, you substitute this value now here. So what do you get? F of z is equal to e power x cos y plus I sin y. Therefore, u plus iv that is equal to e power x cos y plus I sin y. Now you separate the real part and imaginary part. Okay. So when you are comparing real and imaginary part, you will get u is equal to e power x cos y and v is equal to e power x sin y. Here you use this formula, that is this is one function and this is another function. So you will get differentiation of multiplication method, that is d by dx of uv that is equal to u dx into v plus v into d by dx of du. So we know this formula also. Now we apply this formula here. So dou u by dou x that is equal to, with respect to x means e power x cos phi, that is it is in terms of y, therefore it becomes 0, plus then cos y second function d by dx of first. When e power x differentiated, then it becomes e power x. Therefore dou u by dou x is equal to e power x cos y. Similarly, dou v by dou x, you differentiate this v term with respect to x. So you will get e power x, y term is 0 plus sin y e power x. Therefore dou v by dou x is equal to e power x sin y. So you got this. Then dou u by dou y. So e power x, when cos y is differentiated, then it becomes minus sin y. Therefore minus sin y plus cos y into x term is 0. This becomes 0. Therefore dou u by dou y that is equal to minus e power x sin y. Then find out dou v by dou y that is equal to e power x cos y plus sin y 0. Therefore dou v by dou y that is equal to e power x cos y. So now you calculated all the derivatives. Now according to CR, that is Cauchy-Riemann equations, from the equations 1, 2, 3, 4, dou u by dou x is equal to dou v by dou y and dou u by dou y that is equal to minus dou v by dou x. So it satisfies the Cauchy-Riemann equation. This function satisfies the Cauchy-Riemann equation. Also it is continuous. Therefore the given function e power z is analytic. Okay, I hope you will understand this. Now another example you will see. Show that the given function e power x cos y plus I sin y is an analytic function. That is the earlier function itself, earlier problem itself I solved for e power z. So that is the same way, it is separately they are given. So same methodology. F of z is equal to e power x cos y plus I sin y. U plus I is equal to e power x cos y plus I sin y. Then u, v. Then you find out the value of u and the value of v. After that, you should find out the value of dou u by dou x, dou u by dou y, dou v by dou x, dou u by dou y, and dou v by dou y. So all from the equation 1, 2, 3, 4, the equation satisfies, because this function satisfies the Cauchy-Riemann equation, and also it is continuous. Therefore, the given function is analytic. Okay. Now we'll see another different function, whether it is analytic or not. Now you will see. Test the analyticity of the function w is equal to sin z, and hence derive d by dz sin z equal to cos z. So this is another type of equation. Whatever may be, first you should find out from that given function, you separate u and separate v and calculate the derivatives, whether it satisfies, it is analytic. If it is not satisfied CR equations, then it is not analytic. That's all. Now you will see. So w is equal to sin z. We know z equal to x plus iy. Therefore, this equation becomes sin x cos iy plus cos x sin iy. This is sin a plus b. When there is a formula sin a plus b, we know sin a cos b plus cos a sin b. So this is the general formula we know. On that basis, here we are writing sin x cos iy plus cos x sin iy. But when we also know one equation cos iy, that is equal to cos hy. Similarly, sin iy, that is equal to I sin hy. So these two equations also we already know. Now substitute this cos iy and sin iy here in this equation. So what you will get? Sin x cos hy plus I cos x sin hy. So now two terms we arrived. One is the real part, another one is the imaginary part. Therefore, u is equal to sin x cos hy, then v is equal to cos x sin hy. Okay. Now simple. After that it is very easy. Dou u by dou x, that is equal to first function d by dx of second. Here we are partially derivative with respect to x. Therefore, y term becomes 0. Therefore, sin x into 0 plus second function cos hy. When sin x is differentiated, then it becomes cos x. Therefore, dou u by dou x is equal to cos x cos hy. So you find out dou u by dou x. Now similar way you will find out dou u by dou y. Here you are differentiating with respect to y, so x terms becomes 0. Therefore, sin x sin hy plus cos hy, this becomes x, this is x term becomes 0. Therefore, dou u by dou y, that is equal to sin x sin hy. Okay, so you found dou u by dou y. Now you should find out dou v by dou x in the similar manner. Therefore, dou v, you know, v is equal to cos x sin hy. So dou v by dou x means first function, this is y term, so it becomes 0 plus second function sin hy. When cos x is equal to minus sin x, therefore minus sin x. So dou v by dou x, that is equal to minus sin x sin hy. Then you find out dou v by dou y, that is cos x cos hy plus sin hy into 0. Then dou v by dou y you will calculate cos x cos hy. So 4 equations we got. From these 4 equations, it is proved that dou u by dou x is equal to dou v by dou y, and dou u by dou y, that is equal to minus dou v by dou x. So it satisfied the Cauchy-Riemann equation, and also all the derivatives are continuous, hence the given function is analytic. Okay, then another in that problem they want to calculate d by dz of sin z. Okay, it is nothing but d by dz of, we know sin z value already we have calculated, sin x cos hy plus I cos x sin hy, then dou by dou x of change sin x cos hy plus I cos x sin hy. Okay, then you similar way, first function d by dx of second plus second function d by dx of first with respect to x and with respect to y. So sin x, then this cos hy cos x will come, then I cos x 0 plus sin hy minus I sin x. We already calculated in the above four equations. The same methodology we are here using. Then we will get cos x cos hy minus I sin x sin hy. This is similar as cos A cos B minus sin A sin B. This method. For this further nothing but cos A plus B, that is cos of x plus iy. Cos of x plus iy, x plus iy is nothing but z. Therefore d by dz of sin z, that is equal to cos z, hence proved. Okay, hope you may understand these problems also. Now you see another example. I am solving nearly 12 equations for your purpose. You just utilize it then and understand. Now you see another equation. Show that the real and imaginary parts of the function w log z satisfies CR equation. So f of z is equal to log z, same method. This is another type. Here a small change we will have. You see here, in order to separate real and imaginary part, first you put x is equal to r cos theta and y is equal to r sin theta. So this is somewhat different. You just understand this problem. So in order to separate the real and imaginary part, we need x is equal to r cos theta, y is equal to r sin theta. That's all. But we know r is equal to root of x square plus y square, then theta is equal to tan inverse of y by x. These formulas we know. Okay, this is a polar formula, so we know these formulas. Now f of z equal to log z, therefore f of z is nothing but u plus iv, that is equal to log of x plus iy. We know x here, we are substituting r cos theta, and instead of y you substitute I is equal to r sin theta. Okay, then similar method, log r into e power I theta. Log r e power I theta. What is log r? You separate this r term from here. Therefore r log r term will come out. So only other term here is in the bracket cos theta plus I sin theta. We may write cos theta plus I sin theta as e power I theta. This also we know, e power I theta. So substitute, instead of this place you substitute e power I theta. That's all. Okay, hope you will understand. You are taking this r out, therefore log to the base e r, then here the remaining term is in the parenthesis cos theta plus I sin theta. Cos theta plus I sin theta is nothing but e power I theta, therefore you substitute this e power I theta here. Okay, now it is very simple. So log r plus log e power I theta. So now you know log r plus, you remove all log both sides, so we will get log r plus I theta. This e and e terms will go out. So what will become, when we are taking this log value, we will get I theta. Therefore now log r plus I theta is remaining. R we know, u plus iv, that is equal to log of, instead of r you substitute here, from here you substitute r is equal to root of x square plus y square. Instead of the place theta you substitute tan inverse of y by x. You substitute here. So log root of x square plus y square plus I tan inverse of y by x. Now we will easily separate. U is equal to log root of x square plus y square. When you are solving this, then we will get, this is similar as 1 by 2 log x square plus y square. Okay, then v is equal to tan inverse of y by x. V is equal to tan inverse of y by x. So whatever function there is no issues. First you should find out what is the value of u and what is the value of v. It is the basic necessary condition. First you should find out u and v for this type of problems, whether the given function is analytic or not. Okay, now we calculated u and v. Hereafter it is very simple, same methodology. You find out dou u by dou x. So 1 by 2, when you are it is a log when you are differentiating log, then 1 by x square plus y square, because log x is equal to 1 by x, therefore 1 by x square plus y square, then something derivative, so 2x, when x square is differentiated, then you will get 2x, therefore 2 cancel. So you will find out dou u by dou x is equal to x divided by x square plus y square. So you find this equation 1. Now you find out dou u by dou y. Dou u by dou y is equal to the same method. When you are getting dou u by dou y, then this will be y divided by x square plus a simple differentiation. Okay. Now here you will find out dou v by dou x, that is equal to, that is the tan inverse of, when the differentiation of tan inverse, then you will get this formula. Dou v by dou x, that is equal to 1 by 1 plus y square by x square into something derivative, that is minus y by x square. So you see, I show here 1 by 1 plus y square by x square minus y by x square. So common denominator, this x square means 1 by x square plus y square, this x square minus y square, then this x square will go up, therefore x square into minus y divided by this, then x square cancel. So you will get minus y x square plus y square. So for this dou v by dou x, you will get minus y x square plus y square. Okay, so you calculated dou v by dou x. Then similar way you find out dou v by dou y, same method, you will get dou v by dou y is equal to x divided by x square plus y square. So you calculated all the derivatives. Now you find out whether 1, 2, 3, 4 are same. Yes, as per CR equations, dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. Compare the values of equations 1, 2, 3, 4, what we already derived. Hence the function satisfies CR equation, therefore, and also continuous, therefore the given function is analytic. So this problem is somewhat different. You should remember x is equal to r sin theta, then y is equal to that substitution you should give. That is the method, different method here. Okay, sorry. X is equal to r cos theta, y is equal to r sin theta. You should remember for this problem, you should remember this in order to separate the real and imaginary parts. Okay. Now we will see another simple problem. Question is looking like difficult, but it is very simple. If u of xy, that is equal to x square minus y square, is the real part of an analytic function f of z is equal to u plus iv, what is the value of v? Here you should find out, that is f of z is equal to, they have given real part of x square minus y square. Only they have given real part. What will be the value of v? We know u plus iv is equal to real part of x square plus minus y square, but they have never given i. So what will happen? I of 0. So u we know, but v is 0. Therefore when you are finding, so v value is 0. So solution came. Then dou v by dou x is equal to 0 and dou v by dou y also equal to 0. When these two terms becomes 0, 100% it will not satisfy the CR equation. Hence the given function is not analytic. Hence the given function is not analytic. Understand this problem? Okay. Now you will see another simple problem. F of z is equal to real part of z is analytic or not. As similar as the earlier problem, you also see the same one. F of z is equal to u plus iv. Therefore u plus iv is equal to real part of x plus iy. You know u is equal to x. There are no imaginary part because this is I of 0. There is no imaginary part. So v equal to 0, u is equal to x. Similar way, when you are calculating dou v by dou x, it becomes 0. Dou v by dou y, it becomes 0. Hence, it not satisfies the CR equation. Therefore, the given function is not analytic. That is, the real part of z is not the analytic function. Okay. Now you see another form. Check whether f of z, that is equal to mod z, is analytic or not. Similar method only. That is, f of z is equal to u plus iv. That is, u plus iv, that is equal to mod z. We know mod z is nothing but root of x square plus y square. Therefore, u plus iv, that is equal to root of x square plus I square. There is no v term, it becomes 0. There is no imaginary part. Therefore, u is equal to root of x square plus y square, but v is equal to 0. When you are calculating dou v by dou x, it becomes 0. When you are calculating dou v by dou y, it is also becomes 0. When both v terms becomes, both the derivative of v terms in terms of x and y becomes 0, then it will not satisfy CR equation. Hence, the given function is not analytic function. Okay, so this is another simple example. Then another example you will see. I am giving you lot more examples in order to know this type of problem in a good manner. Okay, you follow the things. Check whether f of z is equal to mod z square is analytic or not. We know z value. Similar way, f of z is equal to u plus iv. Therefore, root of z square, z is nothing but root of x square plus y square, so z square. Okay, mod z is equal to root of x square plus y, as similar as the earlier problem. Okay, now u plus iv is equal to x square plus y square. Separate the real and imaginary part. There is no v term, therefore it will not satisfy CR equation. Hence, the given function is not analytic. Okay, then another. Check whether the given function is analytic or not. This is a simple way. F of z is equal to z square, z cube, whatever may be. U plus iv is equal to x plus iy the whole cube. This is nothing but a plus b whole cube formula. So we know a plus b whole cube, what will be the expansion. So x cube plus y cube, iy cube plus 3ab and x. So what it will be? 3iy x plus iy. So this is similar as a plus b the whole cube formula. So you expand the terms and you will get this value, x cube minus iy cube plus you multiply this inside 3ix square y minus 3xy square. So you got. So from this separate a x term, a real part and imaginary part. So u plus iv, that is equal to, this is the real part, x cube is there, this 3x square, 3xy square is there. So you separate it separate. Then I into I terms you separate, you will get 3x square y minus y cube. So u plus v iv, that is equal to x cube minus 3x square minus 3xy square plus I into 3x square y minus y cube. So you know u, you know v. This is u and this term is v. Hereafter it is very easy to find out. U is equal to x cube minus 3xy square. V is equal to 3x square y minus y cube. From that you calculate dou u by dou x. Simple partial derivation, you know, in terms of x and y. So it is very easy. Dou u by dou y. Then dou v by dou x you calculate. Then dou v by dou y. So 1, 2, 3, 4. It is proved that the given function is analytic because it satisfies CR equations and also the derivatives are continuous in the region. Therefore, this given function is analytic. Now, another one equation. This is one new method, new type, but methodology is same only. Find the values of C1 and C2 such that the function f of z is equal to x square plus c1y square minus 2xy plus I into 2x square minus y square plus 2xy is analytic or not. It is looking like a big problem, but it is not an issue. It is a very simple one. Here they have given two constant values, c1 and c2 value. So they want to calculate the c1 and c2 also. Okay, nothing. F of z is equal to, you write this function. After that you expand everything. Then you will find out this. Then you separate a real part and imaginary part. You will get u is equal to x square plus c1y square, that is minus 2xy. Then v is equal to c2x square minus y square plus 2xy. So you know u and you know y. Now you calculate dou u by dou x. Dou u by dou x is nothing but 2x minus 2y. Dou u by dou y, then you calculate, it is c1 2y minus 2x. Then dou v by dou x, that is equal to c2 2x plus 2y. Then dou v by dou y, that is equal to minus 2y plus 2x, that is equal to 2x minus 2y. We will write it in this way. Minus 2y na, we will write it this way. Okay, so you calculated dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Now we want to calculate the value of c1 and c2. So where is c1 and c2? In equation 2 and 3. That is dou u by dou y term we are having on c1. Dou v by dou x term we are having c2 term. So you compare it. So according to CR equations, dou u by dou y equal to minus dou v by dou x. Okay. So you write that equation c1 2y minus 2x, that is equal to minus of 2c2x plus 2y. Now you cut this all two will go out. So what will be the remaining term? c1y minus x, that is equal to minus of c2x minus y. Compare the coefficients of x and y. The coefficients of x and y. So when you are comparing the coefficients of x and y, you will get c1 is equal to minus 1 and c2 is equal to 1. So we calculated c1 is equal to minus 1, c2 is equal to 1. Substitute this value of c1 and c2 in that f of z equation. You will get f of z is equal to x square minus y square minus 2xy plus I into x square minus y square plus 2xy. So you calculated this c1 and c2 values also. Now from the equations 1 and 2, 3, 4, it satisfies the CR equation dou u by dou x, that is equal to dou v by dou y, and dou u by dou y, that is equal to minus dou v by dou x. Hence the given function is analytic. So in this lecture we saw nearly more than 10 problems to find out whether the given function is analytic or not. For these type of problems, first you should calculate the value of u and v, that is you should separate the real and imaginary parts. Then you derive partial derivatives with respect to x and y of that for u and v, that is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Whether these equations satisfy CR equations, that is dou u by CR equation is nothing but dou u by dou x, that is equal to dou v by dou y, and dou u by dou y, that is equal to minus dou v by dou x. If it satisfies, then the given function is analytic. Also you check whether that partial derivatives are continuous. Probably, most probably all will be continuous only when the partial derivative was taken. Therefore we will find out whether the given function is analytic or not. So in this way we will solve the problems. Okay, hope you will understand these things. I will meet you with next topic in a video lecture. Okay, thank you.